So, lesson 1.2. We're going to be talking in this section about randomness and simulation. So, I know we all know the word random and all that stuff, but we're going to talk about what it means in the context of statistics, okay? And again, reason now, best ways we know to generate data that give a fair picture of the world rely on randomness. Things need to be random, okay? So, an outcome is considered to be random if we know all possible outcomes or conclusions that it can have, but we don't know which actual outcome or conclusion that it takes on, okay? And a random outcome is free of human influence. So, very quick example. You're rolling a dice, a six-sided dice. We know there's six outcomes. I know that if I roll a dice, one single, I'm never going to get the number 9 on there, okay? I'm going to get a number 1 through 6. So when I roll a dice, the outcomes, I know them. I know that I'm going to get a value 1 through 6. However, if I roll it, I don't know exactly which number I'm going to get. I can guess, maybe I'm right if I'm lucky. But I don't know exactly which one it is, which is why that's random. When we say free of human influence, what we mean is not that a human is doing something with it. So, for example, rolling a dice. A human has to roll the dice. But let's say a human were to literally pick up a dice, find the number that they want, and drop it and say that they rolled it. That would not be a random outcome because a human influenced what happened. Okay? So that's kind of something that can be confusing for people, is the difference between the two of them. But I want to make sure that I said that. So if we look at example set 1 and we want to know, are these outcomes random or not? So if I look at A, a friend asking you to quickly name a professional sports team, is that sports team random? The answer is no. And the reason is because there's human influence on that. Okay? And there is also going to be bias in the selection. Right? We all know me, Cleveland guy. I'm going to be saying the Cavs, probably, more than likely. But that means that not every other sports team necessarily has an equal opportunity to be picked. Okay? So if I go to B, when playing a board game, the number of spaces you move is decided by rolling a six-sided dice. Are the number of spaces you move random? Yes, they are. Okay? Again, just kind of like I said, even though the human's rolling the dice, that does not mean that it's not random. Okay? If there were interference, that might be a different story. But just rolling a dice, that is random. C, deciding who's going to drive to go to the basketball game. So you flip a coin. If it lands on heads, you drive. If it lands on tails, your friend will drive. Is who drives random? Flipping a coin? Yes, it is random. Again, free of human influence, flipping a coin. You can't necessarily say what the actual outcome will be. You can guess. You have a decent chance of guessing correctly, but we still don't know. D, before flipping a coin, your friend asks you to call it. Is your choice of outcome random? What do we think? Absolutely not. Human influence on that. Right? I'm always calling tails. That's just how it is with my life. Okay? Same reason, there's going to be bias with that. Okay? So, kind of looking at the difference between C and D, calling something, that does, again, normally people have one that they go to. It's quick, okay? So if we go to example 2, many states run lotteries giving away millions of dollars if you match a certain set of winning numbers. A state prints all possible numbers on balls. The balls are placed into a machine, and winning numbers are selected by opening channels that allow one to rise into each channel. So if somebody were to believe this is not random versus if this is random, what do you think are possible arguments they could have about why or why not it is? Okay? So I want you pause it, take maybe like a minute or two, see what you can come up with, then come back, see what I think. So if I were to think that this selection was not random, I can come up with a few things. Perhaps one reason is that maybe there were multiple number repeats printed. We don't know that, okay? Based off of, again, this, maybe the same number was printed 10 times. There's a higher probability that that one gets pulled, okay? Maybe there was some tampering with the machine. Okay? Maybe what the numbers were printed on, maybe those are different sizes. Okay? Maybe those are different weights. All of those might have an impact on if it's truly random or not, right? All of those might be changing something. But if we go to B, somebody who says, yes, this is random, what's the arguments that they could say? Well, they could argue and say that everything is equal size, equal weight, equal color, everything. If that's their belief, okay? Also, when we have these lotteries, is a human actually picking something? No, it's just the machine. So somebody could, with our literal definition, say that there is no direct human influence. It's all a machine, right? So maybe you came up with something different. If you want to talk with me about it, or you want me to check it when I get back, that's completely fine, okay? But those are just some things to kind of get you thinking when you have something that might be random versus something that might not be. Think big thing. Is there bias, or could there be some direct human influence that makes it truly not random? Okay. The next page, random number tables. So, randomly assigning numbers. This is a big thing. All right. So, computers, smartphones, and calculators have all become ways to generate random numbers. However, they're not truly random. We call these pseudo-random numbers. So 2 ways that we get truly random numbers are, first off, tables of carefully generated numbers. These can be found in books or finding genuinely random digits on the internet. So the reason why it's important that we know how to read a random number table and that we know how to kind of assign these random numbers is when we keep moving on with this section, we're going to be talking about simulation, and we're going to simulate how we can figure out something randomly. So to read lines of random number tables, which you're actually looking at right here, there's a very, very small line of one. It's just rows of random numbers. You first need to read the scenario, see how the digits of the table are assigned. And that's seeing how it's represented numerically. Read the table from left to right, mark or note each outcome. And if digits are not part of that outcome that you wanted, you just discard and you keep on reading. All right? So we're going to come back to assignment after. We're going to go through example 3 first. So it says your state's millions lottery has reached $100 million. Could use that. You decide to play, and you have to pick 5 numbers from 1 to 60. If all of your numbers match you in the jackpot, you decide to pick your lucky numbers using a random number table. Based on these random digits, which numbers do you play in the lottery? So I am looking for numbers from 1 to 60, okay? So when it comes to reading these, again, we need to think how these are assigned to us, all right? So digits might be assigned in double digits or single digits. If I'm thinking 1 to 60, the numbers 10 through 60 have double digits, so I need to read this line with double digits, okay? So if we make a side note on that, we are reading by double digits. Okay, and again, the reason why is because I'm going up to 60. I have some numbers that have multiple digits. Okay? When you read a random number table, if you read something that looks like this, it starts with a 0 and then 5, that's representing 5. 0, 7, what's that going to represent? Absolutely, it's going to represent 7. And that's kind of how you read that. Okay? So I go to my random numbers now. I'm marking off starting every 2 digits. So I look at my first 2 digits are 45. 45 falls in my desired range of 1 to 60. So that's going to be a number that I pick as 45. Check. My next two, 9, 2, is out of my range of 1 to 60, so I discard those. I don't care about them, but I keep going. Next one I look at is 1, 0, so that's 10, and I want that. 10 is going to be another number that I select. Okay? Keep marking it. 1, 7, 17 falls in my range, so that's good. I want that. If I mark off again, I get 10. Now, I can't, when you pick a number at the lottery, you can't pick the same number because it's only going to come up once. So I got rid of that. Okay, don't care about that. Next one is 22. 22 is in my range. I'm good. 22. Next two digits, 8, 9, not in my range. Don't count it. And then 2, 3 falls in my range. I want it. So these are going to be my lucky 5 numbers: 45, 10, 17, 22, and 23. Few things about how we read that. So again, we were looking for something that ranged from 0, 1 to 6, 0. Okay? If any other numbers, 0, 0, or 6, 1 through 9, 9 came up, they were discarded. We didn't care about them. Okay? We also had 10 pop up twice. We ignored that. So I also ignored repeats. So these are all things when you kind of look at a random number table and think, how do I read this? These are things to think about. Okay? Can I discard any numbers? Are there any things that don't have an assignment that I skip? Do I ignore the repeats or do I not ignore the repeats? Okay? You got to kind of think, is it simulating a probability or is it actually only that one thing can be picked one time and it can't go back in again? In this case, I can only pick 10 once. With a probability thing, if it can be picked again, you would count that number. Okay? So that's how you read lines of a random number table. If I were assigned something single digit, so it said 0 to 4 was this, 5 to 9 was this. Instead of going every 2 digits, you would go every 1 digit. Okay? There is going to be something like that on your practice. So now assigning numbers. So we were given 1 to 60. Those represented the numbers. Okay? Now we're going to talk about assigning digits. So digits can be assigned in either the range single digits, 0 to 9. Okay? Or what we had on the last one, double digits. So from 0, 0 to 9, 9. Okay? So if you have a scenario with a percentage or outcome in increments of 10, so 20% of something, and then 30%, and then 50%, or 20, 40, 40, again, all of those things, if they are in increments of 10, every single one, you can assign digits single. So 0 through 4 represents this. Okay? If not, anything else, 55 to 45. 65 to 35, 72 to 28. You have to use double digits to kind of simulate that, okay? And you always, always, always start with 0. This is going to be what's going to trip some of you up. 0 counts as a digit, double 0 counts as an outcome, okay? So when you think the range of 0 to 2, that's actually representing 3 outcomes because you have 0, 1, and 2, 3 of them, okay? So I have example 4. So we have the American College of Obstetricians and Gynecologists says that out of every 100 babies born in the U.S., 3 have some kind of major birth defect. How could I assign random numbers to conduct a simulation? So if I'm reading this scenario, 3 out of 100 have some kind of major birth defect. 3 out of 100, that's 3%. So 3% have a birth defect. And if 3% have a birth defect, what percent does not? 97%. So we now need to think, I have 3%, I have 97%. Can I use single digits or do I have to use double digits? I have to use double digits because 97 and 3 are not increments of 10. Okay? So how this works, again, I'm going to start with 0, 0. So I write let 0, 0 through something represent having a birth defect. I need 3 outcomes, so I need 3 values. So if I count again, 0, 0, 0, 1, 0, 2, that's 3 of them. So let 0, 0 through 0, 2 represent having a defect, having a birth defect. And then the rest of them, 0, 3 through 99, represent not having a birth defect. Okay. Those numbers are confusing. I understand. Okay. Everybody always thinks at first it's going to be 00 through 03. But if you think about it, again, 00 is kind of like your starting one counting point. So you're always kind of thinking like one step below where you're thinking. So that's why you end on 2. Okay. So that's one way that I could do it. I also could, if I wanted to flip and represent not having a birth defect first, if I start at 0, 0 and I want that 97%, I need to go up to the 97th value after 0, 0, which again, think one step behind, which would be 96. So I would let 0, 0 through 96 represent not having a birth defect. And then I would let the remaining 3, 97 through 99, represent having a birth defect. Okay. And again, those numbers, they're matching up with the percentages. 97 out of 100 are always going to that not having a birth defect. 3 out of the 100, representing 3%, do represent having a birth defect. Okay? So random numbers, and again, assigning them, I understand can be tough. I am putting on another video that I do need everybody to make sure that you watch about how to also assign when you have single digits and double digits, and you can do both of them. Okay?